Hi everyone. We can use a point plotting table such as this to help us with issues of domain and range, and also to get a sense of how these transformations work. So for example, consider the graph of y equals the square root of x. The domain for this function consists of the non-negative reals. For negative values of x, the function is not real or undefined. And we can do some basic point plotting. But what happens if we go from the graph of y equals root x to the graph of y equals root x all plus 2? Well, for each of the x values in the domain, notice that the y-coordinate increases by 2 units. We go here from 0 to 2, here from 1 to 3, and so forth. So for each value of x in the domain, the y-coordinate, the function value, goes up 2 units. And therefore, the graph goes up by 2 units. If we go from y equals root x to y equals root x all plus 2, notice that we go from 0, 0 to 0, 2. Notice we go here from 1, 1, 1, up to 1, 3, and so forth. Now what happens, so the graph moves up. Now what happens if we go from y equals root x to y equals the square root of the radicand x minus 2? Now notice that y equals 0 when x equals 2 over here on the new graph, but x equals 0 when y equals 0 when x equals 0 on the old graph. So basically what happens at x equals 2 on the new graph happened at x equals 0 on the old graph. Here I'm doing an analysis of X-Intercepts. Look at this warning over here. In case you're confused about horizontal shifts, right, consider the X-intercepts of y equals root x versus y equals root x minus 2. We're asking what values for x will make y equal to 0. Here, it's when x equals 0. Here, it's when x equals 2. So the old graph had an x-intercept at 0, 0. The new graph has an x-intercept at 2, 0. Look over here. Y equals root x. At 0, 0, we have an x-intercept. At y equals the square root of the radicand, x minus 2, we have an intercept at 2, 0. The x-intercept moves right by 2 units, from the red graph to the purple graph. And in fact, that's true for all the points on the red graph as they move over to the purple graph. It may not look like a horizontal shift because we tend to look at things perpendicularly. We try to look at things perpendicularly, but we do get horizontal shifts here. So again, what happens at x equals 2 on the new graph happened at x equals 0 on the old graph. That kind of explains why from here to here, the graph shifts to the right by 2 units. It's kind of like daylight savings time where there's a 2-hour shift. Remember, 2 reasons why horizontal translations are confusing. The 2 S's. Remember, they involve substitution, and we have surprising signs. From the square root of x to the square root of the radicand, x minus 2, not plus 2, if you want to move to the right. Now, more frequently, we can use transformed graphs to figure out domains and ranges. So for example, when we go from y equals the square root of x to y equals the square root of x all plus 2, we're going from the red graph here to the blue graph over here, where we shift the graph up. What happens to the domain and the range? The domain, the x-coordinates we pick up. The range, the y-coordinates we pick up. What happens? Well, the domains stay the same because we pick up the same set of x-coordinates on the red graph and the blue graph. The domain is the set of non-negative reals. It's still the set of non-negative reals, the domain. But the range, what happens to the range? The y-coordinates all go up 2 units. 0 was the least real number in the range for the red graph, but 2 is the least real number in the range for the blue graph. So the range for the new blue graph starts at 2 and then goes off to infinity. Likewise, if we consider going from y equals root x to y equals root x minus 2, the radicand x minus 2, we're going from the red graph to the purple graph over here. What happens to the domain and the range? This time, the domain shifts up 2 units and the range stays the same. The domain shifts up 2 units and the range stays the same as for the original, the non-negative reals. So again, if you understand how a graph is transformed, that may be an easier way to figure out how the domain and the range may or may not be changing. Next up, reflections, more types of transformations.